Historical methods of research. Historical research is a method used to investigate, analyze, and interpret past events, people, ideas, or phenomena. It is grounded in the belief that understanding past occurrences is essential for comprehending present conditions and predicting future trends. In this research method, the focus is on examining past records, documents, artifacts, and other forms of evidence to build a coherent and objective account of historical events. The main aim of historical research is not merely to describe the past but to interpret its significance, how it shaped contemporary life, and what lessons can be learned from it. This method is widely employed in fields like history, sociology, political science, and environmental science when studying the historical impact of environmental policies, species extinction, or deforestation over time. Key features of historical research: analysis of past events. Historical research primarily focuses on studying events, individuals, and movements that occurred in the past. It can span a range of time periods, from ancient history to recent past events, depending on the research question. Use of primary and secondary sources. Primary sources are direct or first-hand evidence from the time period under study, such as letters, diaries, government documents, or newspaper articles. In environmental science, primary sources could include original reports on environmental conditions or early scientific studies. Secondary sources, on the other hand, are interpretations or analyses of primary data, such as books, academic articles, or documentaries written by other researchers. Contextual understanding. Historical research places events or phenomena in the context of their time. Researchers attempt to understand the social, political, or economic environment in which a particular event or phenomenon occurred. For instance, an environmental historian might study how historical agricultural practices influenced deforestation patterns in ancient civilizations. Chronological approach. Historical research typically follows a chronological sequence, tracing the development of a subject over time. This approach helps researchers see how events unfold and how one development may have influenced another. Interpretation of evidence. After collecting the data, historical researchers work to interpret the evidence, creating a narrative that not only describes the events but also provides insight into their causes, implications, and significance. Historical research aims to answer why events occurred and how they shaped present-day understanding. Steps in conducting historical research: defining the research problem. The researcher starts by clearly defining what historical phenomenon or event they wish to investigate. The problem must be precise and researchable, such as, what were the impacts of industrialization on the environment in the 19th century? Collecting data. Historical researchers gather primary and secondary sources of data. Primary sources could include official records, letters, photographs, or legal documents, while secondary sources could include history books, journals, or research articles. In environmental science, primary sources might include early records of air quality measurements, historical land use records, or data on biodiversity. Evaluating the sources. Not all sources are equally reliable. Researchers critically assess the authenticity, bias, and credibility of each source. For example, a government report from the 1800s may be a reliable source, but it may also reflect political biases of the time. Analyzing data. Once the data is collected, it is analyzed to uncover patterns, connections, and meaning. In historical research, this involves understanding the context of the sources, comparing conflicting narratives, and synthesizing a cohesive understanding of past events. Drawing conclusions. Historical researchers then interpret the findings, placing them within the context of their significance. The goal is to understand the implications of past events and the lessons that can be drawn for present and future issues. Reporting findings. The final step is to report the findings in a structured manner, often in the form of research papers, articles, or books. These reports typically present the findings chronologically, analyzing the events or phenomena from multiple perspectives to offer a balanced and comprehensive understanding. Types of historical research. Descriptive historical research. Descriptive historical research seeks to narrate or describe past events in a clear and detailed manner. It does not focus on explaining or interpreting events but rather on presenting a chronological account. For instance, a historic study of the Industrial Revolution may simply document key facts about the period, such as technological innovations, social impacts, and the rise of factories. Interpretive historical research. Interpretive historical research goes beyond mere description to explain and interpret past events. It focuses on causes, consequences, and implications of historical occurrences. Researchers using this approach may explore, for instance, how industrialization contributed to environmental degradation in the 19th century or how it led to the rise of modern environmentalism. Comparative historical research. In comparative historical research, two or more historical phenomena are compared to understand their similarities, differences, and interconnections. For example, a researcher might compare the historical impacts of deforestation in two different countries or regions to understand how political, social, or environmental policies influence ecological outcomes. Historical case studies. In case study research, a particular historical event, period, or phenomenon is studied in depth. This approach provides detailed insights into specific historical instances and can be used to understand complex historical interactions. A case study in environmental science could involve examining a single pollution event and its long-term ecological consequences. Applications of historical research in environmental science, climate change and historical weather patterns. Researchers can study historical weather records to understand long-term trends in climate change. Historical data on temperature fluctuations, extreme weather events, or ice core samples can provide insights into the natural cycles of climate change and how human activities might be contributing to more recent warming trends. Environmental policies and their evolution. Historical research is often used to analyze the evolution of environmental policies. By examining how laws regarding air quality, deforestation, or wildlife protection have developed over time, researchers can understand the shifts in societal attitudes toward the environment and assess the effectiveness of past policy interventions. Historical environmental impact studies. By studying historical environmental changes, such as the impact of industrialization, urbanization, or colonial agriculture, researchers can trace the development of environmental issues. For example, historical research might reveal how early agricultural practices led to soil erosion or deforestation, providing critical insights into sustainable practices for the future. Biodiversity conservation. By investigating historical records of species populations, migration patterns, and habitat destruction, researchers can identify past trends in biodiversity loss. This can inform current conservation strategies by showing which ecosystems or species were previously at risk and the measures that were, or were not, effective. Strengths and weaknesses of historical research. Strengths. Rich contextual understanding. Historical research provides deep contextual understanding of events or phenomena by placing them in their full historical and social context. Prevention of historical repetition. By analyzing past mistakes or successes, historical research helps avoid the repetition of errors in current or future contexts, particularly in environmental policy. Wide scope. It allows researchers to study a vast range of phenomena and offers valuable insights across multiple disciplines, from history and political science to environmental science. Weaknesses. Incomplete data. Historical data may be incomplete or fragmented, making it challenging to draw definitive conclusions. Many records may have been lost, destroyed, or altered over time. Subjectivity and interpretation. The interpretation of historical events can sometimes be biased by the historian's own perspective, leading to skewed or incomplete narratives. No experimental control. Unlike experimental research, historical research does not involve manipulation of variables, meaning that cause and effect relationships can be difficult to establish with certainty. Previous year questions with answers in years. Question 2023. Which of the following is the primary objective of historical research? A. To describe historical events. B. To explain the causes and effects of historical events. C. To conduct experiments based on historical data. D. To develop future policies based on past events. Answer. B. To explain the causes and effects of historical events, asked in UGC Net Environmental Science 2023. Question 2022. What is the primary data source for historical research? A. Observations in a controlled setting. B. Historical records and documents. C. Surveys and questionnaires. D. Experimental setups. Answer. B. Historical records and documents, asked in UGC Net Environmental Science 2022. Question 2021. Historical research is primarily concerned with A. Predicting future trends. B. Understanding and interpreting past events. C. Experimenting to find new solutions. D. Testing hypotheses. Answer. B. Understanding and interpreting past events, asked in UGC Net Environmental Science 2021. Conclusion. Historical research is an invaluable tool for understanding the past and its impact on the present. By analyzing historical records, documents, and other data sources, researchers can gain deep insights into the development of various phenomena, including environmental issues, and help inform contemporary decision-making. Through its detailed examination of past events, this method contributes to the preservation of knowledge and provides a framework for addressing current and future challenges. You said. Qualitative ChatGPT said. Qualitative methods of research. Qualitative research is an approach used to explore complex phenomena that cannot be easily quantified. Inferential statistics. Inferential statistics allow researchers to make predictions or inferences about a larger population based on a sample. Common techniques include hypothesis testing, confidence intervals, and regression analysis. Example, researchers may use regression analysis to predict how temperature changes will affect species migration. Chi-square test. The chi-square test is used to assess whether there is a significant association between categorical variables. Example, the chi-square test could be used to examine the relationship between different waste management methods, recycling, composting, etc., and waste reduction in various regions. T-test. T-test compares the means of two groups to determine if there is a statistically significant difference between them. Example, a t-test could be used to compare pollution levels before and after the implementation of a new environmental policy. ANOVA, analysis of variance. ANOVA is used when comparing chi-square test. The chi-square test is used to assess whether there is a significant association between categorical variables. Example, the chi-square test could be used to examine the relationship between different waste management methods, recycling, composting, etc., and waste reduction in various regions. T-test. A t-test compares the means of two groups to determine if there is a statistically significant difference between them. Example, a t-test could be used to compare pollution levels before and after the implementation of a new environmental policy. ANOVA, analysis of variance. Analysis of variance. ANOVA is used when comparing the means of three or more groups to see if there are any statistically significant differences. Example, ANOVA could be used to compare soil fertility in three different agricultural regions to see if there are significant differences. Advantages of quantitative research, objective and precise. The use of numbers and statistical analysis allows for objective conclusions based on empirical data, minimizing researcher bias. Replicability and reliability. Due to its structured nature, quantitative research is highly replicable, which adds to its reliability. Due to its structured nature, quantitative research is highly replicable, which adds to its reliability and scientific validity. Generalizability. The large sample sizes and statistical methods used in quantitative research allow findings to be generalized to broader populations. Clear, quantifiable data. Quantitative data provides clear and precise results, making it easier to compare and analyze variables. Limitations of quantitative research, lack of depth. While quantitative research is excellent for testing hypotheses and measuring variables, it may not fully capture the complexity of human behavior or experiences. Potential for oversimplification. Quantitative research often reduces complex phenomena to numerical values, which may lead to oversimplification or failure to account for important context. Rigidity. Quantitative research methods are more rigid compared to qualitative methods and may not be adaptable when unexpected data emerges. Previous year questions with answers in years. Question 2023. Which of the following is a characteristic of quantitative research? A. Subjective interpretation of data. B. Use of numerical data. C. Flexible data collection methods. Research. ChatGPT said. Steps of research. Research is a structured process that involves systematic investigation to discover new information, validate existing knowledge, or solve specific problems. The steps of research guide researchers through the process from the initial idea to the final analysis and conclusions. Here's a detailed breakdown of the key steps involved in research. 1. Identification of the research problem. The first step in any research process is identifying a problem or question that needs to be answered. This is the foundation of the entire study, and a clear, focused research problem sets the direction for the research. Example, in environmental science, the research problem could be, how does deforestation in the Amazon impact global biodiversity? 2. Review of literature. Once the research problem is identified, the next step is conducting a literature review. This involves exploring existing studies, theories, and research that are relevant to the topic. The aim is to gain a deeper understanding of the issue, identify gaps in the current knowledge, and build a theoretical framework. Example, reviewing studies on deforestation, biodiversity loss, and climate change to understand the extent of the problem and research that has already been conducted. 3. Formulation of hypothesis or research questions. Based on literature review, the next step is to formulate a hypothesis for quantitative research or research questions for both quantitative and qualitative research. Hypothesis. This is a testable statement that predicts the relationship between variables. Example, deforestation in the Amazon leads to a significant decline in biodiversity. Research questions. These are more exploratory and open-ended, asking specific questions to guide the investigation. Example, what are the primary causes of deforestation in the Amazon? 4. Research design and methodology. In this step, the researcher decides on the research design and methodology to use. This includes determining whether the study will be qualitative, quantitative, or mixed methods and selecting the appropriate methods for data collection and analysis. Quantitative research could involve surveys, experiments, or statistical analysis. Qualitative research could involve interviews, case studies, ethnography, or content analysis. Mixed methods research combines both qualitative and quantitative approaches. The methodology also involves selecting the sample population or subjects, sampling techniques, random, stratified, etc., and the data collection tools, surveys, tests, observation, etc. 5. Data collection. Once the research design is established, the next step is data collection. This involves gathering the necessary information through the chosen methods. Quantitative data could be collected through surveys, experiments, or secondary data, e.g., census data, government reports. Qualitative data could be collected through interviews, focus groups, observations, or document analysis. 6. Data analysis. After data collection, the next step is data analysis. For quantitative research, this involves statistical analysis such as t-tests, ANOVA, regression analysis, while qualitative research requires categorizing and interpreting the data to identify patterns, themes, or trends. Quantitative data analysis. The data is analyzed using statistical software, e.g., SPSS, R, Excel to find correlations, trends, and significance. Qualitative data analysis. The data is analyzed through methods like thematic analysis, content analysis, or grounded theory. 7. Interpretation of results. After analyzing the data, the researcher must interpret the results in the context of the original research problem or hypothesis. This involves comparing the findings to the existing literature, discussing their implications, and determining whether the hypothesis is supported or rejected. Example, if the hypothesis stated that deforestation reduces biodiversity and the data supports this, the researcher interprets the extent and mechanisms by which deforestation causes biodiversity loss. 8. Drawing conclusions. In this step, the researcher draws conclusions based on the analysis and interpretation of the data. The conclusions should summarize the key findings and provide answers to the research questions or the status of the hypothesis. Example, the study concludes that deforestation in the Amazon significantly decreases biodiversity, particularly impacting endemic species. 9. Reporting and presentation of findings. The next step is to report the findings in a clear and organized manner. This involves writing a research paper, thesis, or dissertation, and preparing the findings for publication in academic journals or presentation at conferences. The report typically includes the following sections: Introduction, background, research problem, objectives. Literature review, previous research. Methodology, research design, data collection, and analysis methods. Results, findings from the analysis. Discussion and conclusion, interpretation of results, implications, limitations, and future research. 10. Drawing implications and recommendations. The final step in the research process involves offering implications based on the findings and providing recommendations for future research or practical applications. This could include suggestions for policy changes, further studies, or practical implementations based on the results. Example, it is recommended that stricter regulations on deforestation be implemented in the Amazon to prevent further loss of biodiversity. Future research should investigate the long-term effects of climate change on the region's flora and fauna. 11. Publication or dissemination of findings. Once the research is completed, the findings should be shared with the wider academic community or stakeholders. Publication in journals, dissemination through conferences, or public reports ensure that the research contributes to the body of knowledge in the field. Example, publishing the research in an academic journal on environmental conservation or presenting it at an environmental science conference. Conclusion. The research process is a dynamic and iterative journey that starts with an idea or problem and ends with a contribution to knowledge. Each step is crucial, from identifying the problem to presenting the results, ensuring the research is systematic, reproducible, and impactful. Following these steps ensures that the research is both rigorous and valuable for the academic community or practical use in solving real-world problems. You said. Thesis and article writing, ChatGPT said. Thesis and article writing, an overview. Writing a thesis or an article is an essential part of the research process. Both require careful planning, in-depth research, and clear writing. The Chicago Manual of Style is versatile and used in many different fields, including history, literature, and the arts. It provides two systems for citation, the notes and bibliography style and the author date style. Here we focus on the author date style, which is similar to APA. In text citation, Chicago author date, for one author, author year. Example, Smith 2020. For two authors, author and author year. Example, Smith and Jones 2020. For three or more authors, author et al., year. Example, Smith et al., 2020. Reference list, Chicago author date, books. Author last name, first name, year, title of book, publisher. Example, Smith, John, 2020. Research methods in the social sciences. Sage Publications. Journal articles. Author last name, first name, year, title of article, title of journal, volume, issue, page range. Example, Smith, John, and Ann Jones, 2020. Psychological Development in Children. Journal of Developmental Psychology 15, 3, 123-145. 4. Harvard style. The Harvard referencing style is often used in the UK and is quite similar to APA, but with slight differences. It is widely used across a variety of academic disciplines. In text citation, Harvard, for one author, author, year. Example, Smith, 2020. For two authors, author and author, year. Example, Smith and Jones, 2020. For 3 or more authors, author et al., year. Example, Smith et al., 2020. Reference list Harvard Books. Author, A. Year, title of book, publisher. Example, Smith, J. 2020, research methods, academic press. Journal articles. Author, A. Year, title of article, title of journal, volume, issue, pp. Pages. Example, Smith, J. and Jones, A. 2020, Cognitive Psychology, Journal of Psychology, 23 pp. 123 to 145. 5. IEEE, Institute of Electrical and Electronics Engineers, style. The IEEE style is commonly used in technical fields, such as engineering and computer science. It uses a numbered citation system, where each reference is assigned a number in the order in which it is cited. In text citation IEEE, citations are numbered sequentially within square brackets. Example, 1, 2, 3. Reference list IEEE books. 1. AA author, title of book, XTH ed. 1. AA author, title of book, XTH ed. City, publisher, year. Example, 1. J. Smith, Research Methods in Engineering, 2nd ed. New York, Academic Press, 2020. Journal articles. 2. AA author, title of article, title of journal, volume. XX, no, X, pp, XXXXXX, year. Example, 2. J. Smith and A. Jones, Development of Algorithms, IEEE Transactions on Computer Science, volume. 10, number 2, pp. 123 to 145, 2020. 6. Vancouver style. The Vancouver style is mainly used in medicine and health sciences. Like IEEE, it is also a numbered citation system. In text citation, Vancouver. Citations are numbered in the order they appear in the text. Example, 1, 2, 3. Reference list Vancouver books. Authors, title of book, edition, place of publication, publisher, year. Example, Smith J. Research Methods in Medical Sciences, 3rd ed., New York, Academic Press, 2020. Journal articles. Authors, title of article, title of journal, year, volume, issue, page numbers. Example, Smith J. Jones, The Psychological Development in Children, Journal of Medical Psychology, 2020, 15-3, 123 to 145. Conclusion. Choosing the right referencing style depends on the academic discipline, institutional guidelines, or the publisher's requirements. Each style provides specific rules for citing various sources such as books, journal articles, websites, and more. It's crucial to stay consistent and follow the guidelines accurately to ensure proper academic writing. You said. Application of ICT in research. ChatGPT said. Application of ICT in research. Information and communication technology (ICT) has revolutionized various fields, including research. The application of ICT in research has enhanced the efficiency, accuracy, and accessibility of data, as well as facilitated global collaboration. Researchers today rely on ICT tools and technologies for various stages of the research process, from data collection to analysis and dissemination of results. 1. Data collection and management. ICT tools are vital in modern data collection methods. With advancements in digital technologies, researchers can now collect data in real time through various methods such as online surveys, interviews, and digital sensors. Online surveys and questionnaires, tools like Google Forms, SurveyMonkey, and Qualtrics allow researchers to design, distribute, and collect survey responses efficiently. They can also automate the process of data entry and analysis. Mobile applications. Researchers in fields like healthcare or social sciences use mobile apps to gather data in the field. For example, mobile-based surveys or data collection tools like Evernote help gather field data in real time. Databases and cloud storage. ICT has made it easier to store, access, and manage large datasets. Platforms like Google Drive, Dropbox, or institutional databases ensure data is stored securely and is accessible from any location, allowing researchers to work remotely or collaboratively. 2. Data analysis. ICT has dramatically improved the speed and accuracy of data analysis. Advanced software applications are now widely used for both qualitative and quantitative data analysis. Statistical software. Tools like SPSS, R, and SAS are used to perform complex statistical analyses. These tools allow researchers to process large datasets and generate reports with a higher degree of accuracy. Qualitative analysis tools. For qualitative research, tools like NVivo and Atlas T provide features for coding textual data, identifying patterns, and analyzing qualitative content systematically. Mathematical modeling and simulations. In scientific fields, researchers use ICT tools for creating models and simulations. Software like MATLAB and Mathematica is commonly used in fields such as physics, engineering, and economics for complex mathematical modeling. 3. Literature review and knowledge sharing. ICT has transformed how researchers conduct literature reviews and share their findings. Digital libraries and repositories. Online repositories such as Google Scholar, JSTOR, PubMed, and institutional databases make it easier to access academic papers, journals, and other scholarly publications. Researchers can quickly access and search vast amounts of literature relevant to their research topic. Reference management software. Tools like EndNote, Mendeley, and Zotero help researchers manage citations and bibliographies, organize references, and share resources with colleagues. These tools allow seamless integration with word processors for efficient citation during writing. Open access publishing. ICT has led to the rise of open access journals and platforms like ResearchGate and academia.edu. These platforms allow researchers to share their findings globally, receive feedback from the community, and collaborate on projects. 4. Collaboration and communication. ICT facilitates global collaboration and communication, enabling researchers to work together across different geographical locations. Video conferencing and virtual meetings. Tools like Zoom, Microsoft Teams, and Skype have made it easier for researchers to communicate and collaborate on projects regardless of their location. These platforms also allow for virtual conferences, webinars, and workshops. Collaborative tools. Platforms such as Google Docs, Microsoft OneDrive, and Slack enable real-time collaboration on research papers and projects. Multiple researchers can contribute to a document simultaneously, track changes, and communicate seamlessly. Social media and networking. Social media platforms like Twitter and LinkedIn, and academic networks such as ResearchGate, have become vital for connecting with other researchers, discussing research trends, and staying updated with the latest developments in their field. 5. Publication and dissemination. ICT has significantly transformed the process of publishing and disseminating research findings. Online journals and ebooks. Researchers can now publish their research in digital formats, reaching a global audience instantly. Many journals have moved to digital platforms, providing easy access and quicker dissemination of results. Open access repositories. Repositories like arXiv, bioRxiv, and institutional archives allow researchers to publish preprints or final papers, making their work publicly accessible and promoting wider dissemination. Multimedia tools for communication. ICT enables researchers to create engaging presentations, infographics, and videos to communicate their findings more effectively. Tools like Canva, Prezi, and PowerPoint are used to create professional presentations for conferences or webinars. 6. Ethical considerations and security. While ICT offers several benefits in research, it also brings challenges related to privacy, security, and ethical issues. Protecting sensitive data and ensuring that research is conducted ethically are critical concerns. Data privacy and security. With the increasing use of cloud storage and online tools, protecting the confidentiality of data is essential. Researchers must follow protocols to ensure secure data storage, such as encrypting sensitive data and using password-protected systems. Ethical standards. ICT has made it easier for researchers to adhere to ethical standards by offering tools to track informed consent and participant confidentiality. Platforms that offer digital consent forms or anonymized data storage help researchers maintain ethical research practices. 7. ICT tools in educational research. In the context of educational research, ICT plays a vital role in enhancing learning experiences, both for students and researchers. Researchers in the field of education can use ICT to gather data, analyze learning patterns, and improve teaching methodologies. Learning management systems (LMS) platforms like Moodle and Blackboard enable the collection of data on student performance, engagement, and learning outcomes. This information can be analyzed to enhance educational practices. E-learning platforms. ICT enables educational research on the effectiveness of e-learning tools in digital classrooms. It also allows researchers to conduct studies on virtual classrooms, remote learning, and online assessments. Benefits of ICT in research. Increased efficiency. ICT tools streamline the research process, reducing time spent on manual tasks like data entry and analysis. Improved accuracy. Automated data collection, analysis, and reporting tools reduce human error, leading to more accurate results. Global collaboration. ICT removes geographical barriers, enabling researchers to collaborate across the globe, share resources, and work together in real time. Access to resources. Researchers now have easy access to vast amounts of information, research papers, and tools that are essential for conducting high-quality research. Cost-effective. ICT solutions can reduce the costs associated with physical resources, travel for collaboration, and paper-based publications. Previous year questions. Question: How has the use of ICT enhanced the process of data analysis in educational research? 2021 Answer: ICT tools such as SPSS, NVivo, and R have streamlined the process of data analysis in educational research, enabling quicker, more accurate results. Statistical software provides features for complex data processing, and qualitative analysis tools help researchers identify patterns and themes in textual data. Question: Discuss the role of ICT in facilitating collaboration among researchers across different geographical locations. 2020 Answer: ICT tools like video conferencing platforms Zoom, Skype, and collaborative platforms Google Docs, Microsoft Teams have removed geographical barriers, enabling researchers from different parts of the world to collaborate in real time, share resources, and contribute to joint projects. Question: What are the ethical considerations researchers must keep in mind when using ICT for data collection? 2019 Answer: Researchers must ensure the privacy and confidentiality of participants by using encrypted data storage and secure platforms. Additionally, they should follow ethical guidelines to obtain informed consent and anonymize data to protect participants' identities. Question: Explain the significance of cloud storage in research data management. 2018 Answer: Cloud storage provides a secure, scalable, and accessible solution for researchers to store large datasets. It allows for easy sharing and collaboration, ensuring data is accessible from anywhere and is backed up to prevent data loss. Question: How do social media and online platforms contribute to knowledge sharing and dissemination in research? 2017 Answer: Social media platforms like ResearchGate and Twitter enable researchers to share findings, discuss research trends, and connect with others in their field. These platforms also provide a space for researchers to receive feedback and engage in academic discourse. Conclusion: The application of ICT in research has transformed every aspect of the research process. From data collection to analysis and dissemination, ICT has increased efficiency, accessibility, and collaboration. However, it is important to address ethical considerations and ensure data security to maintain the integrity of the research process. The continued integration of ICT in research will likely lead to further innovations and improvements in the way research is conducted. You said, Research Ethics. ChatGPT said, Research Ethics. Research ethics refers to the principles and standards that guide the conduct of research to ensure its integrity, credibility, and moral soundness. Ethical considerations are fundamental in every stage of the research process, from the design and methodology to data collection, analysis, and publication. Researchers must uphold these ethical standards to protect the rights of participants, maintain the validity of their findings, and contribute responsibly to the advancement of knowledge. 1. Importance of research ethics. Ethics is the cornerstone of responsible and credible research. The significance of research ethics can be summarized as follows. Protection of participants. Research often involves human or animal subjects, and ethical standards ensure their rights, privacy, and well-being are respected. Credibility and integrity. Ethical practices maintain the validity of research findings and prevent misconduct such as data manipulation or falsification. Public trust. Research ethics enhance the public's confidence in scientific